11-HB, factoring completely. That means you use all the different types of factoring methods that you know. So look at the example here, please, up to the right of your steps. Step number 1 is to always look for a GCF. If you don't find a greatest common factor first, then that will make your answer wrong. All right, so look at these three right here. What do these three, all three of them, have in common? Say again? A 3. Good. They can all be divided by 3. Yeah, the 30 doesn't have a 7. They all have a 3 in common, so divide everything by 3. When you do that, it'll make your factoring easier, and it will make your answers correct at the end. So look, we put a 3 in front, and I'll go through this one slowly. Write it down with me. If you put a 3 in front and divide everything by 3, you write what's left over. 30 divided by 3 would make it 10. Are there any variables to cancel? 10j squared. The only thing that would cancel would be the 30 and the 3. That would reduce. What would the next one be? Good, with a negative, minus 9j. And the last one? Good. Now when you go to factor it, you leave the 3 out in front, and all you have left to factor is what's inside the parentheses. And that's just, it's just something to remember. It's not particularly harder, but you just have to remember to ignore the 3 for a minute. So we have to do the 10 times negative 7 is negative 70, and we need negative 9 when we add them together. Anybody come up with those quickly? What's 70 divided by 5? Is that 14? 5 times 14? Okay. So let's use 5 and 14. Which one would be the negative? Okay. Factor boxes. We're not going to use a 30. What should I start with? The 10j squared. Good. 10j squared. And then I split this one up into 5 and negative 14. So those are the ones we're using. Plus 5j, negative 14j, and then go back to the original, it was minus 7. So when you're factoring completely, you just have several things combined together. We found the GCF, now we're factoring the polynomials. When you take out your factors, what are you left with on the top? This one, and then this way to the left, 5j, and then minus. All right, so look at number 1. What does number 1 have in common? A 2. Divide everything by 2. Then you have to put a 2 in the front. That is part of your answer. It's just the part that's done already. So you have to write what you're left with. What are you left with? 12x squared, or n squared? 6n? Oh, sorry, the n and then the minus 6. All right, can I do what we did yesterday right here? Can I do that with a 12 or with a 6? Let me ask that a different way. Is 12 a perfect? Can you take the square root of 12? No, so then we have to do it this way. We can't just do it like yesterday. It would be negative 72 and it would be a 1. The two numbers would be 9 and negative 8. That would work. All right, and I already did the work for you. You don't have to do all the, I can show you the boxes, but for right now, just write down what we get. 2 times 4 and minus 3 and 3 and minus 2. Because I know you know how to do the boxes. I want you to focus on taking out the GCS. But we couldn't do the shortcut from yesterday because you don't know what our 12 doesn't have a perfect square root. Number 4, what can this divide by? 3. Good. Divide everything by 3. Then what? 36. Good. 36x squared and then minus 1. 1. This one was one where you make it a plus and a minus because there was no middle term there. You only can do that when the middle term is gone. All right, look at number 7. Go down just a got a 2 out in front. You've got a 25 and then a what? 20 and a 4. Can you just take the square roots here? With the 25 and with the 4? You can take the square root of 25. Can you take the square root of 4? Yeah. Okay. Will this be a plus and minus problem or will this be a squared problem? Squared. Good. 2 times 5n plus 2 and then squared.
So where does the 20 go? Like, how are you going to get the 20?
It's a shortcut where you don't worry about the 20, but let me show you. See how it's 5n times 2 is 10? And then if you double that, you get your 20. And that's the way it is with all those shortcut words.
Oh, okay. Yeah.
It's the backwards of that. That's right.
Oh, okay.
But since it's a shortcut, we just don't concern ourselves with it. We just, you could do it, but
Yeah, I think I was like,